How Earth is different from other planets. Imagine standing on the edge of a cosmic balcony, gazing out across an endless ocean of stars. Each shimmering point of light represents not only suns, but also the worlds that circle them. Billions of planets dance silently through the void, some scorched by fire, some frozen in eternal ice, some gas giants with swirling tempests larger than Earth itself. Yet, among this vast cosmic gallery, there is one planet that stands apart, one that breathes, sings, and evolves with life. Earth. What makes Earth different from other planets? Why does this small, blue sphere cradle forests, oceans, mountains, animals, and us, while others remain barren, hostile, or alien beyond comprehension? To understand this uniqueness, we must dive deep into Earth's characteristics, comparing them against its planetary neighbors in our solar system and beyond, uncovering the rare recipe that makes our home the only known oasis of life in the universe. From its perfect distance from the sun, to its protective magnetic shield, to the life-sustaining atmosphere and abundance of liquid water, Earth is the product of countless cosmic coincidences. Each factor, fragile and vital, separates it from Mercury's scorched deserts, Venus's suffocating inferno, Mars's dry wastelands, and the cold, gaseous colossi of Jupiter, Saturn, Uranus, and Neptune. In this script, we will journey step by step through Earth's story of difference, examining geology, atmosphere, magnetism, water, biodiversity, climate balance, and human influence. By the end, you'll not only see why Earth is different, but also why its uniqueness is both a wonder and a responsibility for all who call it home. When comparing Earth to other planets, one of the most fundamental differences lies in its position within the solar system. Location, in the grand scale of cosmic architecture, is destiny. Earth is the third planet from the Sun, nestled comfortably between Venus and Mars. This seemingly simple fact is perhaps the greatest key to Earth's uniqueness. Unlike the fiery furnaces of Mercury and Venus, or the frozen deserts of Mars and the outer worlds, Earth rests in what scientists call the habitable zone, or the Goldilocks zone. This is the narrow band of space around a star where conditions are neither too hot nor too cold, but just right for liquid water to exist on a planet's surface. Liquid water is more than a substance. It is the lifeblood of life. On Mercury, so close to the sun, temperatures swing from blistering heat to freezing cold, making liquid water impossible. On Venus, the greenhouse effect traps heat so effectively that surface temperatures melt lead, erasing any chance of oceans. Mars, though it once held rivers and seas, lost much of its atmosphere and became a frigid, desiccated world where water exists only as ice or in briny trickles. Earth, however, sits at the perfect distance, where sunlight warms the surface just enough to sustain vast oceans, rivers, and rain cycles, creating the foundation for life. The solar system itself is structured like a cosmic orchestra, and Earth plays a unique note within it. To its advantage, Earth is shielded by the gas giants Jupiter and Saturn, which act as celestial guardians. Their immense gravity captures or deflects many comets and asteroids that could otherwise threaten Earth. Without these outer giants, Earth might have faced catastrophic impacts more frequently, potentially preventing life from flourishing. This protective arrangement is not guaranteed for all planetary systems. In many exoplanetary discoveries, planets sit unprotected, at risk of bombardment, or exist in chaotic orbits that destabilize any chance of long-term habitability. Earth's orbit is also nearly circular, which means it maintains a relatively stable climate. Contrast this with Mercury, which has a highly elliptical orbit that subjects it to extreme changes in solar heating, or Pluto, whose eccentric orbit and tilt make it endure dramatic seasonal changes that last centuries. Earth's stable orbital path ensures that seasons, though shifting, remain predictable and balanced enough to support agriculture, ecosystems, and civilizations. Another unique aspect is Earth's axial tilt of about 23.5 degrees. This tilt gives Earth its seasons, a rhythm of change that stimulates biodiversity and ecological balance. On other planets, the story is very different. Venus barely tilts, resulting in no significant seasonal variation. Its climate is uniformly hostile. Uranus, on the other hand, tilts almost completely sideways, causing bizarre, decades-long seasons that would challenge life as we know it. Earth's moderate tilt brings variety without chaos, a balance that nourishes life across latitudes. Even Earth's relationship with its moon makes it different from other planets. The moon, unusually large compared to Earth's size, stabilizes our axial tilt. Without it, Earth's tilt could wobble chaotically over millennia, creating erratic climate shifts that might disrupt the long-term development of life. In this sense, Earth's very location, orbit, and companionship with the moon make it strikingly unique when compared with its planetary neighbors. Thus, Earth's position in the solar system is not a matter of coincidence. It is a masterstroke of cosmic alignment. It is close enough to the sun to benefit from its warmth, far enough to avoid its fury, shielded by distant giants, and steadied by its moon. These differences set Earth apart fundamentally, creating a stage where water, atmosphere, and life itself could emerge and thrive. If Earth's position in the solar system gave it the chance to host life, then its atmosphere gave it the means to sustain that life. The atmosphere is not just a layer of gases, it is a protective blanket, a chemical factory, and a climate regulator. Without it, Earth would be little more than another barren rock orbiting the sun. What makes Earth extraordinary is that its atmosphere is unlike that of any other planet in our solar system. Earth's atmosphere is composed of about 78% nitrogen, 21% oxygen, and trace amounts of argon, carbon dioxide, and other gases. This composition is profoundly unique because of one key element: oxygen. Oxygen, especially in such abundance, is exceedingly rare in planetary atmospheres. It is not a naturally stable gas. It reacts easily with rocks and other elements, meaning it would disappear over time if not constantly replenished. On Earth, it is replenished by one of the most extraordinary processes in the cosmos: photosynthesis. Plants, algae, and cyanobacteria continuously release oxygen into the atmosphere, turning Earth into a living, breathing system where life sustains the very conditions needed for its survival. Contrast this with other planets. Venus, Earth's so-called twin in size and composition, has an atmosphere that is almost entirely carbon dioxide, with thick clouds of sulfuric acid. Its atmospheric pressure is about 92 times that of Earth's, equivalent to being nearly a kilometer underwater. The result? A runaway greenhouse effect that traps heat and pushes surface temperatures to over 465 degrees Celsius. Far from nurturing life, Venus's atmosphere is a suffocating, crushing prison. Mars, by comparison, has a thin atmosphere, less than 1% of Earth's pressure, and it too is mostly carbon dioxide. Because of its thinness, Mars cannot retain heat effectively, leading to extreme cold. Its weak atmosphere also fails to shield the surface from harmful solar radiation and cosmic rays, making it a dangerous environment for any would-be life. Earth, on the other hand, has an atmosphere thick enough to provide protection, yet not so thick as to choke the planet in heat. It strikes a balance that is both delicate and perfect. Then there are the gas giants: Jupiter, Saturn, Uranus, and Neptune. Their atmospheres are dominated by hydrogen and helium mixed with methane, ammonia, and other exotic compounds. These atmospheres are so hostile that any attempt at human survival would be impossible. There is no surface to stand on, only crushing pressures, turbulent storms, and poisonous gases. In fact, Jupiter's Great Red Spot is a storm larger than Earth that has raged for centuries, a reminder of how violent and alien such worlds are compared to our serene blue planet. Earth's atmosphere also serves as a shield. High in its upper layers lies the ozone layer, a thin band of ozone molecules that absorbs harmful ultraviolet radiation from the sun. Without this protection, the delicate molecules of DNA in living organisms would be shredded by radiation, making complex life impossible. Venus and Mars lack such a shield, leaving their surfaces exposed to intense solar energy. Beyond shielding, Earth's atmosphere also regulates temperature. Through the greenhouse effect, a natural process where certain gases trap heat, the planet maintains a climate warm enough for liquid water, yet cool enough to prevent the runaway heating seen on Venus. The balance of gases is so finely tuned that even slight changes in carbon dioxide levels can shift the global climate, reminding us of how fragile this atmospheric balance truly is. The atmosphere also gives Earth something no other planet has: weather and climate diversity. Winds, rains, storms, and clouds create a dynamic environment that recycles water, distributes heat, and nourishes ecosystems. While other planets have storms, none exhibit the complex, life-supporting cycles of Earth. On Mars, dust storms may engulf the planet, but they bring destruction, not renewal. On Jupiter, storms are eternal, but they occur in an environment too violent for life. On Earth, weather is not only survivable but essential, driving the cycles that sustain forests, farms, rivers, and oceans. Thus, Earth's atmosphere is far more than air. It is the breath of life. It is a unique cocktail of gases sustained by the very organisms that depend on it, a balance unknown elsewhere in the solar system. This atmosphere makes Earth not just habitable but hospitable, a nurturing cradle in a cosmos where most planets are hostile wastelands. If there is one feature that most visibly distinguishes Earth from all other planets in the solar system, it is water. From space, Earth gleams like a sapphire, its surface dominated by shimmering blue oceans, swirling white clouds, and polar ice caps. This abundance of liquid water has earned our world the name the Blue Planet. No other known planet in our solar system, or even among the thousands of exoplanets discovered so far, possesses such vast, stable reservoirs of liquid water on its surface. Earth's oceans cover more than 70% of its surface, containing about 1.3 billion cubic kilometers of water. This water does more than just fill the basins. It drives Earth's climate, nourishes ecosystems, and provides the essential solvent in which life's chemistry takes place. Water's unique properties, such as its ability to absorb and release heat slowly, help regulate Earth's temperature, ensuring the planet remains within the narrow bounds that allow life to thrive. Now compare this to our planetary neighbors. Mercury, with its thin exosphere and searing heat, has no water to speak of, although tiny deposits of ice survive in permanently shadowed craters near its poles. Venus, with its infernal atmosphere, once may have had oceans, but the runaway greenhouse effect boiled them away long ago, leaving behind a desolate, arid world. Mars is the most tantalizing in this regard. Ancient river valleys, dried-up lake beds, and mineral deposits tell us that billions of years ago, Mars had flowing water. But today, it exists mostly as polar ice or locked underground, with only small, seasonal trickles of briny water. The gas giants, Jupiter, Saturn, Uranus, and Neptune, harbor water in the form of vapor, ice, or deep layers hidden within their massive atmospheres, but none have accessible oceans like Earth. Some of their moons, however, such as Europa, Enceladus, and Ganymede, likely have subsurface oceans beneath layers of ice. While these are fascinating and potential homes for microbial life, they are sealed away in darkness, nothing like Earth's open seas that teem with biodiversity. On Earth, water is not confined to one form. It is everywhere, cycling through oceans, rivers, lakes, glaciers, clouds, and even underground aquifers. This hydrological cycle, evaporation, condensation, precipitation, and runoff, is one of the defining features of our planet. It ensures that water is constantly renewed, distributed, and accessible to living organisms. No other planet exhibits such a dynamic and life-supporting cycle. On Mars, when storms rage, they lift only dust, not water. On Venus, clouds rain sulfuric acid, not fresh water. Only Earth has a self-sustaining water system that blankets the planet with life. Earth's water also plays a crucial geological role. Oceans act as engines for plate tectonics by lubricating Earth's crust, allowing continents to drift and mountains to rise. Without water, Earth's geology would be static, and the recycling of nutrients and carbon would falter. Water also shapes landscapes. Rivers carve valleys, glaciers sculpt mountains, and waves shape coastlines. Over billions of years, water has been both a sculptor and a life giver, leaving Earth with a surface that is dynamic, diverse, and breathtakingly beautiful. And then, of course, there is ice. Earth's polar ice caps and glaciers store vast amounts of fresh water, reflecting sunlight back into space and helping regulate global temperatures. No other planet has this intricate balance of liquid, vapor, and solid water coexisting on such a grand scale. Even the moons with hidden oceans lack this planetary variety, where water is visible, accessible, and woven into every aspect of the biosphere. What makes Earth's water even more astonishing is how it partners with life. Every organism on Earth depends on water. It is the medium in which life's molecules interact. Human civilizations grew around rivers and seas, relying on water for agriculture, transport, and survival. Even now, modern economies and cultures are built upon this liquid foundation. Without water, there would be no rainforests, no coral reefs, no fertile plains, no humanity. Thus, water is not just another feature of Earth. It is the very essence of its uniqueness. In a solar system where most planets are dry, frozen, or scorched, Earth stands as the only world with seas that shimmer under sunlight, rivers that flow endlessly, clouds that drift across blue skies, and rain that nourishes green landscapes. It is water, more than anything else, that transforms Earth from a rock into a living planet. While Earth's oceans and atmosphere give it a dynamic character, its geology reveals an even deeper uniqueness. Unlike its planetary neighbors, Earth is not a static or frozen world. It is alive with motion beneath its crust. The surface of our planet is shaped by plate tectonics, volcanic activity, earthquakes, and mountain-building processes that continually recycle and renew the landscape. No other planet in our solar system exhibits geological activity on the same scale or with the same life-sustaining consequences as Earth. At the heart of this difference is plate tectonics. Earth's outer shell, the lithosphere, is broken into several large plates that float atop the semi-molten mantle below. These plates are in constant motion, colliding, pulling apart, and sliding past each other. The result is a world of continuous change. Mountains rise, oceans open, continents drift, and earthquakes rumble. This mobility is unique to Earth. Venus and Mars may show signs of volcanic activity, but they lack the complex system of moving plates that reshapes Earth's surface. The gas giants, being composed largely of gases and ices, have no solid crust at all. Plate tectonics plays a vital role in Earth's habitability. When plates move, they drive the carbon cycle, recycling carbon dioxide between the atmosphere, oceans, and rocks. This regulates Earth's climate over millions of years, keeping it stable enough for life. Without this process, Earth could have ended up like Venus, with carbon dioxide building uncontrollably in the atmosphere, or like Mars, where the lack of geological recycling left the planet cold and barren. Earth's geology, in this sense, acts like a thermostat, maintaining conditions suitable for life. Volcanoes are another defining geological feature. On Earth, they are not merely destructive, they are creators. Volcanic eruptions release gases that helped form the early atmosphere, minerals that enrich soils, and land masses that eventually became fertile regions for ecosystems and human civilizations. The Hawaiian Islands, the Andes, the Italian Peninsula, all are born from volcanic fire. On other planets, volcanoes exist, but they tell a different story. Mars is home to Olympus Mons, the largest volcano in the solar system, towering 3 times the height of Mount Everest. Yet Mars's volcanoes are extinct, remnants of a planet that is cooled and quieted. Venus has volcanoes, too, but they erupt into an already suffocating atmosphere, offering no life-sustaining benefit. Earth's volcanoes, though sometimes dangerous, are part of a cycle that sustains life rather than stifling it. Then there are the mountains. Earth's mountain ranges, such as the Himalayas, Rockies, and Alps, are monuments to tectonic motion. They form when plates collide, pushing land upward in slow but powerful movements. These mountains shape weather patterns, create habitats for diverse species, and inspire human cultures with their majesty. In contrast, the mountains of Mars, though enormous, are static relics. They are products of single volcanic events, not ongoing tectonic processes. On Earth, mountains are not fossils of a distant past. They are evolving features of a living planet. Earthquakes, though feared, are also evidence of geological vitality. They release energy from the shifting plates, reminding us that beneath our feet lies a restless interior. On a lifeless world like Mercury, the crust is solid and immobile. On Mars, quakes are faint and rare. But on Earth, seismic activity is a sign of an active planet, one constantly reshaping itself and renewing its surface. Another remarkable feature of Earth's geology is the diversity of its landscapes. Deserts, forests, mountains, plains, and coastlines coexist, offering countless ecological niches. This diversity is the direct result of geological processes working in tandem with atmosphere and water. Other planets, by contrast, are more uniform. Mars is a cold desert world. Venus is a furnace wrapped in toxic clouds, and the gas giants are swirling storms without solid ground. Earth alone combines variety with habitability. Perhaps most importantly, Earth's geology works hand in hand with life itself. Plate tectonics ensures nutrient cycling, volcanic eruptions provide fertile soils, and erosion by rivers and glaciers sculpts new habitats. Life, in turn, influences geology. Plants break down rocks, microbes interact with minerals, and humans now move mountains with machines. This symbiosis between geology and biology is unparalleled in the known universe. In short, Earth's geology sets it apart as a living planet. Its restless crust, dynamic interior, and continuous recycling processes distinguish it from its barren or frozen neighbors. While other planets bear scars of ancient eruptions or impacts, Earth wears its history like a living tapestry, constantly rewritten by the forces of motion, fire, and water. It is this dynamism that allows Earth to remain fertile, diverse, and capable of supporting life through the ages. As we explore what makes Earth different from its planetary siblings, one invisible yet powerful factor emerges as a true guardian of life: the magnetic field. Often overlooked because it cannot be seen with the naked eye, Earth's magnetic field is one of its most extraordinary defenses, shielding the planet from cosmic dangers and enabling life to flourish in safety. Without it, Earth might resemble Mars or Venus, harsh, barren, and stripped of its protective atmosphere. The source of this magnetic shield lies deep beneath our feet. Earth's outer core, composed mainly of molten iron and nickel, is in constant motion. This churning liquid metal generates electric currents, which in turn produce a magnetic field through a process known as the geodynamo. The result is a vast, invisible bubble of magnetism surrounding our planet, called the magnetosphere. The importance of this shield becomes clear when we compare Earth with other planets. The Sun constantly emits a stream of charged particles known as the solar wind. Without protection, these particles would strip away a planet's atmosphere over time, leaving it exposed to radiation. This is precisely what is believed to have happened to Mars. Once, Mars may have had a magnetic field and a thicker atmosphere, but as its smaller core cooled, the field weakened and disappeared. With no protection, the solar wind eroded Mars's atmosphere, leaving behind the thin, fragile blanket of gas we see today, a world where liquid water cannot survive on the surface. Venus, despite being similar to Earth in size, also lacks a strong magnetic field. Instead of a protective magnetosphere, Venus relies only on a weak induced field generated by its interaction with the solar wind. This flimsy shield is no match for the Sun's power, leaving Venus's atmosphere exposed to intense radiation. Though Venus retains its thick carbon dioxide atmosphere due to its sheer density, the lack of magnetic protection contributes to its hostile conditions, with no hope for life as we know it. The gas giants, Jupiter, Saturn, Uranus, and Neptune, do have magnetic fields, some even stronger than Earth's. Jupiter's magnetic field, for example, is so powerful that it creates intense radiation belts deadly to spacecraft and humans. But these giants lack solid surfaces and Earth-like conditions. Their magnetic fields, while impressive, do not serve life in the same way Earth's does. What sets Earth apart is not merely having a magnetic field, but having one that is perfectly tuned for life. The magnetosphere deflects most of the solar wind, funneling only some particles toward the poles, where they interact with the atmosphere to produce the breathtaking auroras, the northern and southern lights. These shimmering curtains of green, red, and purple light are not just beautiful spectacles, they are visible reminders of Earth's shield at work, turning danger into wonder. Beyond deflecting solar wind, Earth's magnetic field also protects the planet from harmful cosmic rays, high-energy particles that stream in from distant stars and galaxies. Without this shield, these rays would bombard the surface, damaging DNA, increasing mutation rates, and making the planet far less hospitable for complex life. Even Earth's atmosphere owes its stability in part to the magnetic field. By preventing solar wind from stripping gases away, the magnetosphere ensures that oxygen, nitrogen, and other vital components remain in balance. Without this invisible shield, Earth's air might have thinned long ago, leaving us gasping for survival. The magnetic field also plays a subtle but profound role in navigation for both nature and humanity. Birds, sea turtles, and even some bacteria use Earth's magnetic field to guide their migrations. Humans, too, have long relied on compasses that align with the magnetic poles to explore and map the world. This connection between the magnetic field and life, both instinctive and technological, is yet another thread weaving Earth's uniqueness. In summary, Earth's magnetic field is a silent guardian, a cosmic shield that stands between life and destruction. While other planets either lack such protection or wield it in ways irrelevant to life, Earth's magnetosphere is perfectly suited to its role, preserving the atmosphere, protecting living organisms, and even inspiring awe through the auroras that dance in polar skies. It is an invisible difference, yet one of the most critical factors that make Earth unlike any other world we know. When we speak of how Earth is different from other planets, all scientific explanations, position, atmosphere, water, geology, and magnetism, ultimately lead to one astonishing result: life. Earth is the only known planet where life not only exists but flourishes in astonishing diversity. From microscopic bacteria deep within the ocean floor to towering redwood trees, from colorful coral reefs to vast savannas filled with grazing herds, Earth is teeming with living systems. This biosphere is what truly sets Earth apart in the silent, barren landscapes of its neighbors. Life on Earth is not a singular occurrence. It is a symphony of billions of species interacting in complex ecosystems. Scientists estimate that Earth is home to around 8.7 million species, though many remain undiscovered. These species occupy every imaginable niche: the scorching deserts, the icy poles, the deep oceans, and even boiling hot springs. No other planet in our solar system shows even a trace of such complexity. On Mars, despite decades of exploration, we have found no conclusive evidence of life, only the faint possibility that microbes may have existed billions of years ago when water still flowed. Venus, once considered a potential twin of Earth, is far too hostile for life to survive. The gas giants and their moons hold promise of microbial life deep beneath icy shells or in subsurface oceans, but none display surface ecosystems like Earth. As far as we know, our planet stands alone as a thriving oasis of biodiversity in a vast cosmic desert. Earth's biodiversity is also dynamic. Species evolve, adapt, and diversify, shaped by natural selection and environmental pressures. This evolutionary dance has given rise to incredible variety: birds that soar, fish that swim, mammals that nurse their young, and humans who ponder their place in the universe. Life here is not static but constantly reshaping itself, adapting to Earth's shifting climate, geography, and chemistry. Another extraordinary aspect of Earth's biosphere is its interconnectedness. Plants release oxygen, animals breathe it in, and both return carbon dioxide to the atmosphere, maintaining a balance that sustains all. Oceans teem with plankton that not only form the base of marine food webs, but also regulate global carbon cycles. Forests store carbon and produce moisture that influences rainfall worldwide. Even the smallest microbes play essential roles in breaking down waste, recycling nutrients, and supporting larger ecosystems. This web of life is unique to Earth, a planetary scale system where every organism contributes to the balance of the whole. Perhaps most remarkable of all is the rise of intelligent life, humans. Among the billions of species, humanity has developed consciousness, culture, and technology, allowing us to reflect on our existence and explore beyond our home. No other planet in the solar system, as far as we know, hosts beings who can gaze at the stars and ask, "Are we alone?" This ability to question, create, and shape the environment is itself a defining difference, turning Earth not just into a living planet, but into a thinking one. Earth's biodiversity also holds a beauty unmatched by any known world. Coral reefs shine in colors more vivid than any Martian landscape. Tropical rainforests echo with the calls of countless species, unlike the silent plains of Venus. Snow-covered mountains harbor unique creatures, while deserts pulse with life adapted to extreme conditions. This tapestry of ecosystems is both fragile and resilient, offering endless wonder to those who live within it. And yet, Earth's biodiversity is not invincible. Human activity, deforestation, pollution, climate change threatens to unravel the very systems that make Earth unique. Unlike Mars, where lifelessness is permanent, Earth's living systems depend on balance. If disrupted too far, they may collapse. This gives humanity not only the privilege of living on the most extraordinary planet, but also the responsibility to protect it. In short, biodiversity is Earth's crowning difference. While other planets are barren rocks or swirling gas, Earth is alive, bursting with movement, color, sound, and adaptation. Life here is not an accident, but the result of billions of years of cosmic fine-tuning, geological activity, chemical balance, and planetary protection. And in this living world, Earth is not just a planet. It is a miracle.